Hello, so I'm presenting Simbol. Simbol is basically identity with a use case. So my use case is mainly focused in virtual and augmented reality. People are now creating loads of virtual worlds for virtual reality, mainly social VR. So worlds for like nerdy things like manga or films, just a place to hang out with friends, or like education virtual worlds. And their users, they want their users to be able to move around these virtual worlds with their same identity, with their same avatar, with their username, even with their digital objects that work throughout all these virtual worlds. So currently I'm focusing on VR on the web, based on a standard called WebXR. And like when the web started and many people started flourishing with creativity and creating all these websites on GeoCities and all that, we're starting to see something similar with VR. So this is an identity system for those folks. Several companies have already asked for this. Basically, we don't have enough tooling for VR yet, and identity systems is one of those things that people just aren't bothered about creating. So Simbol provides this for them. Simbol is a very basic identity system built on top of these specifications that we're working on that provides virtual world creators something that they can offer their users. So their users can simply create an avatar, create a display name, and then move between virtual worlds seamlessly, like we've seen in science fiction. So this is a simple prototype that I've been working on over the last 3 weeks, so it's still very, very early stages. I hope to have an MVP by April. And basically you get in here, you click register, pick an avatar. This will be like a more elaborate 3D avatar creator system. Select, then you get your display name. And basically here what's happening is that you're creating your public profile. This is based on verifiable claims. And they're basically self-signed claims. And by the time that you finish the process, you've already created your identity, which was happening in the background, and you're signed in, and this is showing your public profile. I can actually show that here. Put debug mode. Here, this is the DID that's loaded up, and this is the verifiable presentation with the claim for the display name and for the avatar. And there will be a developer library that they will be able to interact with this web identity manager app. And so people will be able to seamlessly move between virtual worlds and log into them without having to press any buttons. User experience is the main focus for this. So you don't even hear about blockchains, hear about DIDs. You just click register, click logging. You probably won't even need to click logging, and that's it. So yeah, finished. The idea is that it should be simple, so.
Beautiful. Thank you, Alberto. Any questions for Alberto? Please step up to the right.
As one of the editors of the verifiable credential spec, thank you so much for doing it the right way. Even the URLs, that must have been fairly recent because like the namespace URLs changed for the context, and you got that right as well. So thank you.
I think I did that bit like a week ago, so.
Can you put inventory stuff in there with you yet?
Not yet, probably like a month.
Cool. Awesome.
Okay, so my demo is about verifiable displays. So displaying verifiable credentials in HTML. So first of all, I want to show you this text, this demos. What is this? This is a verifiable credential, simple example from the spec. Basically, it's a JSON file, and that's perfectly fine. This is the verifiable credential with proof. We can cryptographically check it and verify. But the problem with this credential for me is that, well, it's JSON. It's not human readable, at least for normal humans, right? So currently, the display of verifiable credential is locked into the wallet that displays this credential. And I do not see like the spec, the standard that explains how to display verifiable credential in a standard way. So there is no true portability of verifiable credentials as of me. If you receive, let's say you receive a degree from university, You have this degree, you received it into the wallet, you check it, you verified it, you can even send probably this verifiable credential to someone else, but they also have to have this wallet to check it, right? So from the same provider. So I think this is one of the biggest sins that can be committed, is kind of vendor lock-in. In a way, you limit the control, the freedom of a person. The person doesn't have full control over their credentials. So basically what I want to have is to be able to download my credential, let's say my degree, have it as a file, be able to see it, not in JSON format, but in human readable format, and send it as attachment by email. And the receiver can also download that attachment and verify it. So how I see it can be done? Well, we can put verifiable credential into HTML and then hash part of that HTML to have integrity of that display. So let's see the example on the contract. So here we have a contract, right? It's written, it's a little bit broken, but it's written in a human readable way. You just see it as a usual document. And here we have JSON layer, so the verifiable credential that has the reference to the HTML, to the display of that verifiable credential. And I just see the picture, the signatures, and I can also see if it was tampered or not. So if something was changed, it is tampered. So the demo is a little bit broken, but I hope you've got the idea to have JSON layer and to have presentation layer. So to have the files completely portable and truly human readable, right? So I hope you have any questions.
Great, thank you. Any questions for Bohdan? Please step up over near Ganesh. Let's go and get you set up on it as we handle questions.
I have one question. There you go. What are you hashing? Are you hashing the HTML and then the JSON LD inside it, or are
No.
you've got a link? Like, is it like a hash link or a?
Yes, so right now it was done before the hash link and all of that. It's the old demo.
Okay, there it is. It's towards the bottom. Okay.
Yeah, so we are going to use hash link, multi-hash, multi-base hash link, and there is the question that I need to clarify how to use it. And what we hash is div in HTML. So we take the visible part, the first div in HTML, and hash it and put it into some hash link in a JSON file, in verifiable credential. And then we pack it all together in one HTML file, and that's it. This is one portable, everywhere, truly portable and everywhere displayable, right? So this is usual HTML file. You can put this as an attachment, and you can double click. So I can, I have this, let's say, certificate of completion, right? I just double click, it opens. So I can send it to my grandma and say, hey, here I have my degree. She opens it and she sees it. And if she wants to verify that there is a digital signature from the university, she goes to her favorite verifier and puts that So let's say it's Validbook statements, like some service that verifies documents. She just drags that certificate of completion there, and it says, okay, there is a signature is valid. Right now it was tampered, so maybe something was wrong. So this is the idea.
Cool. Okay. Hello, everybody at Rebooting Web of Trust. My name is Boima, and I just wanted to speak a little bit about a project I've been working on that I think is, at the very least, auxiliary to this group, and potentially maybe could be a piece of like infrastructure that could be used. So I work on a project called Handshake. It's essentially a decentralized naming project. In particular, it's a decentralized DNS project. And so what we did shortly was we took the DNS root zone file and embedded it in the state of a Bitcoin-like blockchain. And then we also facilitate auctions through a UTXO covenant-like system, or said a different way, a way to restrict where payments may go from one coin to another on a blockchain. And doing this, you can kind of design a state machine that resembles an auction. So this is what we've done. So at a high level, what you can do is auction off names from the DNS root zone. So the reason we did this was we wanted to see if there was a way we could decentralize the certificate authority system. Right now, certificate authorities are a central weak point in our internet security, right? Like a CA could get hacked, and then, or a user at a CA with access to the key could issue false certificates, and then people can spoof people online. And so in this way, if you buy a name on Handshake, then the name is rooted in trust by a blockchain, and then signing a signature could kind of represent a proof of ownership of this name, or proof of control, as this community likes to say. And so when I got here, I was thinking that potentially we could use Handshake as a way to kind of bring human meaningful names to DIDs, and then I kind of went down the rabbit hole of that, and I'm still going down the rabbit hole of how that may not be something that is wanted in the community. And so I kind of just wanted to put that out there to show what we're working on. And anybody here can come up to me and kind of ask me about things, or see if there's any way we could use this for maybe a local names like thing, or pet names like thing, or whatever you think about this project. And so right now, actually, I wanted to show you all that I wanted to update a name, but like the process takes a while. The auctions, you need to I don't know, it would be too long for this time span. But I just wanted to show you all that right now, because we embedded the root zone file, I can actually run Handshake on my machine, a resolver. Essentially, quickly what I wanted to show you is that if I go into my DNS settings, network, advanced, so my DNS is pointed to localhost port 53, and I'm actually running this top right quadrant is a full node. So this is actually running as an authoritative name server on the network for the TLD zone. And then this bottom quadrant here is actually a light client to the blockchain, and also a name resolver. So a recursive name server. And so in a setting where you were just a user, you could just run this recursive name solver and not have to worry about running the full node and just hit a node on the network. But for reg test purposes, I have to run both nodes. And I can browse the internet. I didn't have time to post a new name. I wanted to send an update and have it show Web of Trust, but I didn't have time. But you can browse the internet, GitHub resolves. Let me think of does anyone know a .io? Oh, no, I already went to weboftrust.info. I could go to purse.io, not to shill the company I work for, but and I don't know, I guess I'm just browsing the internet like we always do, but I'm not using any other resolver but the Handshake name resolver. So that's it for me. If anybody has any questions, let me know. And if not, come ask me about Handshake and how the software could help this community evolve. Or if I need to shut up about human meaningful names, feel free to tell me that too.
All right, thank you, Boyman. Any questions for Boima? So I do have one. You have one? Go ahead. So when you auction off a name, where's the money go?
Yeah, so when we auction off names, so Handshake is its own chain, so we have miners, and miners validate the network, and then they're issued block rewards. And these coins are how you participate in auctions on the network. But when you actually, the way the covenant system works is you send money into, there's a two-step process. First, you think about what you want to bid, and then you lock up a value that's higher than that bid to obfuscate the bid. And then in the second step, you reveal the bid, and revealing the bid traps the money, the bid amount into that covenant and gives you back the difference. And now that money is effectively burned. It doesn't go to the miners, it doesn't go to like some Handshake foundation, it just like is burned off the network, right? It stays in that covenant, so it can't be used to do anything except for like stay on this covenant. And this covenant is essentially an output, and the output is where you update your name records. So whenever somebody, when your resolver tries to query the network, what it does is it looks for the name, actually it looks for the coin that leads to that name, and then queries the metadata on the coin and finds the name records or whatever records you have that it needs to use to point to where you're looking to go on the internet. So, long story short, no one gets the money. Miners get the fees for the transaction, but.
How are you preventing, so there are a bunch of DNS names that are already registered out there, right?
Yeah.
How are you making sure, do you have your own TLD that
No.
you're operating as? Here's the ultimate question. Have you talked to ICANN's lawyers about this?
Yeah, so
Okay.
we've been in, I haven't talked to ICANN's lawyers, but the team has been in communication with ICANN. So what happens is we don't have our own TLD. What we've done is taken the existing top-level domain namespace and embedded it on the chain. That's how our resolver is able to resolve the regular internet, because we've basically taken com and net and org and the 1,500 TLDs that already exist and embedded it into the system. And right now, those names are in a reserved state, so there is no key that owns those names, but we have a system for claiming where if the owner of the TLD essentially supports DNSSEC and then can submit a ZNXSEC ownership proof to the chain, then they will be issued the name on chain. And we also, to kind of avoid I'm an early user because I helped build the software, so I could buy up all the cool names. The Alexa Top 100,000 rankings list, we've also taken the subdomains of those names. So Nike.com, for instance, you can't buy Nike.com on Handshake. It's reserved for the owners of, you can't buy .Nike on Handshake because we're only dealing with TLDs. It's reserved for the owner of Nike.com. Yeah. We also have some other cool tricks to kind of make sure all the names don't get used up at the beginning of the network. Every week a new batch of names is released, and the names are based off, what we do is we take a hash of the name and then operate modulo 52 on it, and then that number will be a number between 0 and 51, and that's the week in the first year in which you are even eligible to buy the name. So we're trying to make it to where the distribution of names is fair. Yeah. As fair as possible.
Okay, thank you, Boima.
Thanks, everyone.
Okay, thank you.
I'm the author of Digital Trust Protocol, and the intention of the Trust Protocol is to create a base layer of trust on the internet. The vision is to extend the human trust system onto the digital space. And this was a longer slide, so I'm just gonna skip some. Basically, I am state, assume that DTP's perspective of trust is the belief that as person or system will behave predictably, even under stress. I believe that trust is the basis of identity and reputation and security. With a decentralized trust system, you can start building up your own web of trust. And then I would like to just demonstrate that on a Twitter client that I have implemented. First of all, I've logged in with my DCP account. It's the organization. And the browser extension had added some buttons to each account. In this case, that DCP, for some reason, doesn't like Elon Musk, so it has distrusted him. But they like SpaceX. And that's DTP's organization's opinion of different accounts on Twitter. Now I can log in with my personal account over here. Just have to, change something. So the extension is that you have a pop-up where you can submit, or you can state your address as your identity on Twitter, external TCP identity. And if we look at Elon Musk and SpaceX, there's nothing here. So if I go into Trust Protocol and I start trusting them, what happens here is that I'm trusting one of my peers, so I'm delegating out trust to them. So their decision of who and who not to trust will affect me. I can, in my client, decide how their trust affects me. I can decide if they distrust somebody, I will hide the content. I can also mute them or block them automatically, so that I don't have to go through that process. I can auto-follow, and so on. And if I go back to looking at SpaceX, I can see now that I'm trusting SpaceX, even that I haven't trusted them personally, but I'm doing that through my trusted peer. And if I look at Elon Musk now, you can actually see that his content is hidden from me, so I'm not having to filter that data automatically, or that he can, or I can auto block him as well if that's the purpose, and I can see why. So basically, this is the intention of this system, is that you can have a trusted peer of network of peers, and they will help you filtering the information you're getting from the internet. And this system will also work on Reddit and forums and basically everything. You can use it on news articles, you can use it on reviews on computers and so on. The last thing is that the protocol also supports claims of chain of trust. In this scenario, we have a state that's sharing a public key, and they are trusting the division, department, employee, and employee trusts your credentials. And this creates a chain of trust. This chain of trust you can take with your credential and provide to a verifier. The verifier is trusting the state, so he can, in combination with his own trust and your chain of trust, actually verify that the credentials are trusted by the state, and he trusts the state. This works in with any authority. It doesn't need to be a state, it can also be a bank or whatever you like. But this is a system that allows you to actually prove the credentials validity of your credentials even offline.
We need to wrap up, Carsten.
Yeah, so that's it.
Great.
Yeah.
Excellent. Thank you. Any questions for Carsten? Step over to Ganesh. Reeks has the microphone.
My question is,
Farhan, if you could come in, please.
if my friends trusted someone, I will see it on whatever network who they trusted, so I should trust also. That's correct, right?
Yeah, as I didn't show the, you have the possibility when you're trusting and distrusting people that you can also see when you're getting the result back, you can actually click a button and you can get a visualization. It will be kind of this visualization, and you will get like a way to see, okay, how did I get the trust from my network and how that did the aggregation of trust. Is that the answer?
Yeah, I mean, my question was it, what is the trust score based on the trust from my friends, or is it aggregated from around the internet?
Basically, what happens is that it's a complex, human trust is a complex thing. So what I'm doing, I'm kind of narrowing it down to the most simple form I can imagine, and that's binary, by saying either I trust or I don't trust you. That's it. And the result I'm getting back from my web of trust is what the server has, and it just gives me what the result is, and it's actually up to my client to decide how to interpret that result. That makes sense?
Yeah, so your client interprets the results of your web of trust?
Yeah, exactly.
Okay. And what is the incentive of your web of trust to create all of these trust signals? Why should they do this?
The system works by the assumption that trust is hard to gain and easy to lose. So that will create an incentive to people staying on the right side of things.
That's okay. To gain reputation and keep your reputation, that's important. That's understandable. But why other people should, they can like it, they can retweet it, but what is their incentives to also click one more button to say I trust?
Yeah, that's the thing. I have noticed that Twitter accounts that have a lot of followers, some of them have stated they're on the verge of giving up because they're getting so much bad feedback from other accounts, and they don't have time to clean up all those block or mute them manually. So if they can delegate out that responsibility to trusted peers that can help them filter out that information and also validate what accounts is worth following, I think this is a valuable feature for a lot of people. It will be nice that I have a help from my peers to kind of filtering the information I'm getting and filtering out the information I don't want. So that's the incentive to use this system.
Great. Thank you very much.
I just want to give you a quick demo about where we are working on at Rabobank. I will show you a demo about the identity wallet, where we made an abstraction layer called the ULA, Universal Ledger Agent, with multiple modules, for instance, to issue DID documents to the Ethereum or Sovereign blockchain. We also made a component called SSI as a service to increase adoption, and it's basically a Docker image where an existing party, existing software can connect to using 2 API calls to issue or verify credentials. We use standards for like BIP 32 for key derivation, JSON LD signatures, We use DIDs, verifiable credentials, and verifiable presentations. The last one also for credential issuing. So I think we are unique in that, and also if you have opinions about that, I would really like to know. So the flow I will demonstrate to you is that you have a holder, so that's the identity app we are working on. I'll show it on my iPhone. It will scan a QR code, which then connects to an endpoint, and the holder will receive a challenge request. And his response will be his DIDs with a proof of ownership of the DIDs, so that the issuer can verify credentials on those DIDs. Also, the issuer is placing the DID in the blockchain, for instance, to check if it's not revoked, and also for timestamping. In the next step, the holder will issue his credentials in a VP to the verifier and also prove ownership of the DIDs. So let's move to the demo. On the right side, you see my iPhone with the identity app. So the first time a user starts the identity app, you can retrieve his personal identity to the identity app. So that's where we use authorities, unfortunately, because we have to use them within the processes within Rabobank. So one can retrieve his personal identity, and like an EID. We don't have a real EID in the Netherlands now, but we have a system called IDIN. It's supported by all banks, and you can use it to retrieve your identity. So in this demo, I can just select my bank account from a list, but normally I would use like a really small device from Rabobank to verify my identity. When I click login, the verifiable credential will be sent to my iPhone, and it's stored there, and the DID is placed in the blockchain. So now you can see my personal information in the identity app. Well, and we still use the attester terminology, but I think it's, we should change it to an issuer. And on the left side, you see Hyperloan. It's just one of the projects we work on within the Dutch Blockchain Coalition. It's like a project to request a loan only by using verifiable credentials. So when somebody wants to apply for a loan, he can just enter some information about well, how much money he needs, how he wants to pay it back, and then he can choose to provide his personal data in the traditional way, so with papers, PDF, and handwritten signatures, or using the identity app. And you can imagine that with the identity app, we as Rabobank have better data, we can verify the data, and we can also automate our processes. So for the user, it can be a cheaper option when he uses the identity app. When he chooses the identity app, he can see which information he has to provide. So he has to provide some personal information using IDIN, and his financial information using VIII, since I only have, so it's like a financial institute in the Netherlands that has all the incomes. Since I only have 1 minute left, I will not go to the UWV website to get my financial information. But I will just scan the QR code now with my identity app. And you can see that it has found my personal information, but not my financial information, since I didn't retrieve it to the identity app. And this screen asks for explicitly consent to share my personal data. And when I select to share it, you will just see that it pops up. And it has also verified that the data was not revoked and that the signatures are valid. So that's where we're working on, and Hyperloan is just a proof of concept we are doing now. We're also doing proof of concepts to have a verifiable resume, and also for KYC processes within our bank. So that's basically it. Thanks.
Excellent. Thank you, David. Any questions for David?
Okay, so I'm going to talking about the social key recovery, and I think we have mentioned a lot in yesterday, and we just provide an alternative way as from the traditional. We split the the C phrase into multiple shares to your trusted contacts. Okay. So we use Jamil secret sharing. It is a method to split secret into shares, and it is able to recombine later. So in our design, we design 3 out of 5 trusted contacts can help you to recover the C. Okay, so how can users connect with their friends? Basically, you need to send out an invitation, and you can pick the frequently used communication app, and we will help you to compose an invitation and with an deep link. Deep link means the URL shortener, and it can embed parameters, and it can support multiple platforms. So either your friend is using Android or iOS, we can both guide them to the App Store or Play Store to download the app and complete the backup process. So there's a question that how can users verify their friends as trusted? So here we throw a 6-digit verification code. The verification code is generated by the trust zone, and also shown by the hardware. So you just need to find a way to tell your friend the 6-digit. Either you just show him a screen, or you can call him, or you can send an SMS text to him. So your friend just easily type the 6-digit in the app. That's done. Okay, so another thing is how can we make sure the user data is secure and not compromised by the weakness of Android? So the idea is quite simple. We use the hardware. So the data passed through the user and your trusted contacts are all encrypted. And we verify the code, and we generate the code are all inside the hardware. So all the data passed through Android is invisible. Okay, the last thing is how can we solve the data stored on the friend's device might be missing? So we have a health reporting. So basically the custody's device will send the health status routinely, and the user's device will check the status. So that's just simple. And we also design a simple revoking mechanism. You can cancel the share stored on your friend's device. You can remove that. Okay, so that's a basic idea that we have. And if you have any, before we see the demo, so if you have any feedback, you can just send an email address, because somebody told me my name is really hard to remember yesterday. So, okay. So we have a 1-minute demo to just very quickly go through the process that I just mentioned. Where's the mouse? Okay. So you send an invitation to your friend. So your friends will receive an invitation. And just type his name. And now the hardware will generate 6 digits. your friend, you will need to pass the 6 digital to your friend. And that's done. This is the first content, right? So the second one has the same process. And the third one. That's done. That's a whole backup process, and the recovery is just a reverse process like that. Okay. Thank you.
Thank you. That was great. Any questions for Han Kwon? Okay.
Okay, please.
We'll get you a microphone, Katrina.
Super stupid question. Really stupid. If I have the first device and I'm able to see that those 3 friends are already connected through some other social messaging, you know, is there any way to, if you have the first device, is there any way for you not to be able to go through that flow and basically spoof that you're reaching out to those 3 friends?
So, do you mean that you want to see how many friends you already?
No, what I'm saying is if I have the first device and I've stolen it, right?
Yeah.
And now I'm trying to do that recovery.
Yeah.
Is there any way? And I think, okay, I can see there are these 3 friends that they message a lot. So I'm going to try and go through this flow and guess that it might be these 3 or 5 people, and be able to do the social recovery by being able to do that.
Yeah. So when you want to restore your C, you will maybe you buy a new phone, right? So after you need to log in account, and we will list the 5 names that you have asked them to help you to back up your C. So and then you need to invite at least 3 of them to help you recover the C.
I can talk to you afterwards. I think I'm just trying to see whether there's a step in there somewhere that can stop somebody coercing you to do this. That's all. But it's really impressive. Thank you.
Okay, thank you.
How then dynamic it is? Can I change, add, revoke? Like if I add some friends and it's not me losing my phone, but it's my friend losing their phone, so I can like delete and add them and rewrite the whole process.
Yeah. So basically we have a monitor mechanism. So the owner will know your friend is already not reporting the health message. So maybe he changed a new phone, or maybe he lost his phone. So at this moment you will need to resend the share to your friend. So you can just have a UI just simply click. Yeah.
Chris.
So how are these messages being transmitted? Over what networks? Obviously the requests are being sent through Telegram or whatever, your mail or whatever, but once you're actually doing this deep link, where is that happening?
Okay, so the basically deep link is just help you to help your friend to download the app. So, and we will embed some token. That token is used to, your friend will need that token. It's just an ID to communicate with your device. So we embedded a token number inside the deep link. The deep link just only help your friend to download the app.
I have a similar question about the health messages. Are the health messages sent through any central server? And how do the phones find each other to send the health messages?
Sorry, what message?
The health messages, the checks to see if your friend is still connected. Okay,
so basically your friend will install an app to help you back up the C, right? So that app will routinely to send a message back to the owner's device to tell the owner that the device is still, the share is still healthy.
Is that direct connection?
Yeah,
to
direct
the
P2P,
IP
just a
address?
P2P message.
How do they find each other? How do they find which IP they're using at the moment?
Okay, so when they first type back the seed, they will create a connection. So your friend will store the token ID in their device, in his device. So and then daily they will report the status via the token ID. That's a P2P ID.
Is the token ID then mapped to an IP address through some server?
Yeah, currently we use Google FCM, and we are looking for another solution, another P2P solution.
Thank you.
Yeah.
Okay, so IPID is basically publishing the DID document using IPLD, interplanetary linked data, to the IPNS namespace, which is basically under IPFS. For some of the details, you can see my last white paper from the Rebooting Web of Trust in Toronto, where I discussed the generalized framework of using IPLD as a framework for publishing the DID document. In my case of IPID, I'm publishing it to the IPNS namespace, which is basically a key value store on IPFS. When I originally did this for Rebooting Web of Trust 6, I think in Boston, I guess that was 5, it was 0 lines of code. So basically you create your DID document and you basically IPFS, name, publish the document. So I've since then created some Go code to wrap this. And here's an example of the IPID resolve that DID document. Here's the result of the DID document. There are some deviations from the DID specification, and I did that because I have some security concerns that I've submitted some issues for. But some of the details, if I can swing around and see over here, behind the scenes, let me go back to that. It basically does an IPFS DAG get, and here's the value that's published to my IPNS namespace, so the same document. But the beauty of this is that you can actually traverse, let's see, my public key. You can get the first public key. You can also get the @context, which is in my case an IPLD link there. And that's better than a URL, which is the issues I submitted. But also, since IPID is not itself a blockchain, nor is IPFS, we're using blockchains to anchor the truth of this proof as a proof of existence of this document existed at some point of time. So in this, there's actually up here the proof, which is actually a deviation from the DID spec. In there, they use signatures as proofs. I will have to rename these. The signature here is the CBOR serialization that's signed with the public key as presented. The proof is actually a smart contract that actually is just a simple proof of existence. So you can actually independently go to this link, look at the code, see the transaction, and see that indeed the hash of this CID existed at that point in time. The reason being is 10 years from now, I could have just generated all this on the fly and you just trust all of my timestamps. You need independent validation that my DID document existed 10 years in the past. So lastly, we do support namespaces. So go back to here. So we do support namespaces because that actually IPNS does resolve to namespaces. So if you go to johnnycrunch.me, that is just as valid. And actually, this is all offline. So actually, I've been having issues with Wi-Fi because we're saturated. So I'm actually right now off of the Wi-Fi, running an IPFS node, and this still independently connects and actually validates the key value pair cryptographically. I'll take questions. Oh, you know what?
Thank you, Johnny.
One more thing.
Any questions? That was very cool.
And here is an example of a verifiable claim You can tag it, but basically this is a verifiable claim for a vaccination, in this case the flu vaccination, using IPID.
The reason I wanted to share this demo or overview with you very quickly this afternoon was around some of the things that have come up around interoperability, and there's some amazing stuff that is happening obviously in rebooting Web of Trust, and it's happening across SSID, and some great ideas, but actually getting them into either production or getting them out there into a use case is not so easy. So we know that there's a lot of greater stuff happening under the bonnet, and we've been focusing on the application layer and enabling end-to-end use cases where there may be a number of components where you in the audience may actually have a component for an end-to-end use case, and we're focusing on the API and the experience and application layer to make that something that's super convenient and something for people to be able to use in their everyday life. So very quickly, our mission or vision is to enable everyone on the planet to get equity and value for the information they share. And we see that part of what we're trying to do through this community is find more equitable business models where there's a lot more transparency about how data is shared. And we see that one of the challenges for us as a community at the moment is there's super amazing things happening, but they're still being done in some degree in silos. So we have a lot of work around data portability, we've got amazing work happening around SSID, and then there's work around consent management. And what we're focusing on is the application layer to enable these end-to-end solutions to be able to bootstrap this really, really quickly into something that can be integrated through a connection directly with an enterprise or a use case that's really simple for people to navigate, even though there may be some really cool new tech under the bonnet. So we have a wallet for iOS and Android and web, which will enable you to be able to push really beautiful looking verified claims. Obviously, as we get closer to the standards being complete, we will be incorporating the DID standard, the verified claims, and doing work with Kantara around consent receipts. We have a consent ledger now that will generate per attribute a UUID with a set of permissions, and those permissions can be controlled by the user. We also generate a personal ledger, and by integrating with our API, you can decide what you want to send to that personal ledger. So it could be the device that someone's logged in with, what data they've shared, who they've shared it with, the conditions of sharing that, and this belongs to the user, this ledger. So over a period of time, they start to build up a digital twin, if you like, which is quite unique in terms of devices they've used, people they're connected with, data they've shared. Equally, if people revoke data or change consent, that also comes up in their personal timeline. And we're also supporting in the EU under open banking and GDPR a data marketplace. So an ability for individuals to be able to bring data from different places. And then we have a set of APIs where under open banking, PSD2, GDPR, we're working with organizations to actually deploy white label versions of these wallets, again, as kind of a Trojan horse for enabling an enterprise to fulfill their requirements of data transparency, data portability, but also for individuals to gain a lot more agency in terms of the way they're able to use their data. We published a white paper about 9 months ago on zero-knowledge proofs and the work that we're doing in the Hyperledger community right now, and specifically focusing on progressive disclosure and how you can start to run the business logic for a business application like applying for a mortgage or credit directly on the customer's data on their wallet rather than actually collecting that data. And anyone that wants to see kind of a demo of this, or our apps are already in the App Store, but I thought I would just contextualize this with some of the things that we're doing. So here's a white label version of something we've built for a bank that shows an individual being able to bring their own SSID or their own identity provider into a mortgage application, and at the end of it, a data wallet is generated. Another example of emergency cash where they're able to use the data that's in their wallet to actually get access to cash or reorder a card. Another example is microinsurance, which is an integration between an insurance provider, a card operator, the person's data wallet, and the card issuer to be able to insure something at point of sale. Here's
we
faster.
need to wrap up, Katrina.
Okay, so there's a whole range of use cases. What I wanted to show was that there is more than just identity. There's more than these individual building blocks. So how do we start to enable some of you guys in the audience that are doing some really cool things? How do we bring those things together? Yeah? Thank you.
Thank you, Katrina.
My name is Martin Riedel. I'm with Identity.com. Identity.com is the open source community framework that is utilized by Civic. So we put our tech in there and make it available for others to use and be able to join the ecosystem. So we've seen this image quite often before. So the triangle between, we call it a requester, which is a verifier, a user, which is a holder subject, and a validator, which is generally the issuer. So what I want to specifically present today is the IDV Validator Toolkit. So in this direction. The demo is going to be quite technical, but please, if you have any questions furthermore, come and approach me. So we have frameworks for each of these individuals. So for the requester, it's a toolkit to ask for credentials, to specify the requirements onto a credential. The credential wallet is, of course, the user-facing code to manage personal keys and personal credentials and hold them in a wallet. And the Identity Validator Toolkit is the toolkit to issue credentials to a wallet, but also to run through the validation process. So I give you a quick demonstration on how you would approach that. So what you're looking at now is a credential wallet demo put into a web application. So this is a demo app for integrating what we call credential wallet, and I'm running through debug mode here to give you a little bit of impression. So it's setting up keys, whatever it would do on a wallet, but in this demo, we're specifically saying we're asking for credentials, and we call this a credential request. Excuse me, where is it? Here we go. Sorry. So the credential wallet app is asking, I mean, I copied it in here so we can just see it. It's asking for something like this. So some website that I've been calling requests from me to provide a certain credential with certain constraints. And there's an identifier database behind it that is run by Identity.com. So it's asking to provide this credential. And what then happens is that the credential wallet can run along and find possible validators that are registered in a ledger that can provide this credential. So credential matches, it's exactly this. So if I type this in here, so the result is something like, you are missing that credential, so the wallet knows I cannot provide that credential to you, but there are requesters that are able to provide that to you. And then the DID gets resolved, and there is a service that then points you to the requester. So now running through this here, what you would then do is you would initiate a validation flow. So you know the endpoint, you know what credential you want to request. So you can request a credential. Please, no more. Okay, it's definitely Murphy's Law. Of course, I've deleted. Okay, it's working now. So I'm initiating a credential request for a credential item, and then the process is guiding me through a validation flow. So it's an interface for validators to join the ecosystem and for our credential wallets to understand what validators need to collect. So we're in the process before even issuing a credential. This community always starts, all right, how do we issue credentials? But we are defining a standardized protocol for users to approach issuers to provide validated data to them. So now I can retrieve the process, and this specific requester, sorry, it's is asking for certain information. So it's asking for a name and an address and a date of birth and an email and a social security number and a phone number. And in sake of time, I'm trying to do it quick. So because of this process definition and the UCA, we're calling it, definition, the user knows in what format it needs to provide the validated data. So, for example, I'm providing my phone number. I just got a token for that. And in the next process, and you can see it here, if I retrieve the process, it's asking for a known phone number and also supports APIs like, oh, you have dependent properties that you need to provide. And every property has some kind of retry count, for example. Okay, just the phone number validation real quick. So I can send, I already sent my phone number, so I sent the token and send this with a patch. And now if I retrieve the process, I can see that it's that the phone number has been accepted. And if you run through every process, that at some point you would get to the get credential point, and the credential module would issue you a verifiable credential that you can retrieve. So long story short, IDV Validator Toolkit is a toolkit that we can offer people that want to issue verifiable credential and collect dependent data in order to join the ecosystem and issue credentials to our credential wallet app. And we're trying to use as much standards as possible. So if people want to standardize this protocol, please come and talk to me. Any questions?
Thank you, Martin. Any questions for Martin? Yes, we have one here. Microphone.
Hi. Regarding the protocol you're talking about, how that's fit with this, maybe I got it completely wrong, with the claim manifest that is going around on the Distributed Entity Federation?
So you're asking about the relation to the credential manifest that we're trying to work on the...
Yeah, so you're part of that. Okay, so it's all aligned.
We are aligning it. So this initiative started before the credential manifest, but it's exactly the definition.
Okay.
So just out of context, the DIF is starting a push to define a credential manifest, which is exactly in correlation to this. So an issuer can publish a credential manifest in order to publicize what data needs to be provided, also other credential, in order to issue a credential. And yes, we are aligning these things right now. But this push was started before the credential manifest push. Any other questions?
I think that was my question, is how do you get the list of things to go and gather prior to the issuance? And
exactly. And in the version of our identity.com provided, it only collects unverified information right now. So the claim manifest, of course, also wants to extend that principle, and you can provide me already verifiable credentials in order to get new verifiable credentials. And we don't need it for our use cases at this step, but we're extending it to not only ask for unverified information, but already verified information, which is the same protocol or protocol definition a verifier asks a user for these informations. So these information need to be standards the same way on both sides.
Because that matches very well with identity proofing and verification standards from the policy side, that approach.
Yes. And so just to summarize, these are standards that happen outside the issuing or providing of verifiable credentials, but we also must tackle these problems at some point in order to provide a interoperable ecosystem. All right. Thank you very much.
Thank you, Martin.
Hello guys, I'm Martin Czernyi from Bot Labs, and we are building the Kilt Protocol. And this is, on the basic level, we want to enable users to create claims, request attestations, send these to attesters or issuers who would issue credentials based on these claims, and then the user can obviously take these credentials to verifiers who can verify them. But on another level, we would like to also enable the representation of more complex trust structures that can model real-world trust relationships. And as a main contribution, we would like to incentivize the convergence of claim schemas to the most usable ones in different use cases to facilitate the interoperability and investment security for the participants. We use a blockchain in the background based on the substrate framework to store revocable attestations and to register the hash of these claim schemas, which we call C-types. So now Timo will show a small demo of our client prototype that uses this protocol.
Hey, yeah, I'm Timo. I will just quickly show the prototype. It's not cloned, so I have to figure out where my mouse is here. Martin told you about the so-called C-types, which are JSON schema definitions of specific use cases. So, for example, we have the driver license, which then has a schema with some properties, like name and age. And from that on, we can make claims. So if we see here, we have, for example, this claim, which is just filled out information from the JSON schema. I already prepared the attestations with an attester, which is just a little workflow where I just select the here and say which attester I want. I have to say also this is a prototype, right? So everything is working via a centralized messaging service, and currently I'm everyone. I'm the claimer, I'm the attester, I'm the verifier. I will just quickly show what I would do as a verifier. I would go to my contact where I want to, from whom I want to get my claim, or attested claim, we call it. Attested claim is basically a verifiable credential. And I will go to the claimer, and he is requesting a claim for a specific C-type. I can select an attested claim. Also, like say, I only want to show my name and also the attesters I have for this specific claim. It's sent. And if I go back to the verifier, I get the information about the claimer. The age is hidden, and cryptographically it's still proven that it's inherently valid. And you see the attester. One thing I forgot to show, sorry about that. Okay, I don't see it right now. Oh, okay, it's not in this form. I will just tell you, we also have a concept called legitimations. So actually the attest of the attest I got also included legitimations, which says, for example, I as the attester am actually a company. So I will put my attested claim inside this attest for the user, so later on I can present this attested claim to someone else and he can see, I don't know this attester, okay, but I see he has actually a valid attested claim from someone I trust, so I trust him. And also we have a concept which is called a deck of trust, which is more an authoritative approach where you're giving someone delegation rights or attestation rights, so you only have to trust one common root but you can give some delegation rights or attestation rights to someone in your company or your structure. So these are the first two concepts we have there. Yeah. Any questions?
Great, thank you. Any questions?
Sure.
Right here.
Hello, Carsten here. The claims you're creating, how are you storing them, and are you sharing those claims with third-party entities?
So everything is stored locally. The only thing we are storing somewhere else is the attestation hash on the blockchain. Otherwise, we are having this messaging system, which is encrypted and signed, which can go over any protocol. We are imagining using DID service endpoints for that. So you can just send the encrypted message containing the claim to the tester or verifier in this case. Yeah.
Thank you. Any other questions for Timo?
Okay. What I would like to add is we're really looking into using DID from others. So we want to use third-party DIDs, and we are actually here a little bit to talk about how to make it interoperable, because we would like to consume every DID which is out there and make claims and attestations with them. All right.
Okay, great. Thank you.
Thank you.
I changed my presentation. I was intending to do something else. We can do that offline. Why the hell are we actually doing this, and how we try to foster involvement from where we stand, right? So we are not talking about identity. We are talking about enabling business transactions. That's why we want to do that. So what's a business transaction? Here is an example. Citizen fills in a form, for example, for a parking permit. Then, of course, these examples exist in finance, health, education, etc. So this is not about parking permits. Filling in a form not only requires typing stuff, but also uploading PDF files, which can be cumbersome. And then basically this is paper made electronic, right? So you still need a person to actually validate the information on the form, by which I mean to check whether or not the information can be used in an argument to make a business decision. And businesses are self-sovereign, which for us means that they get to decide what is true, they get to decide what is valid logic within them, and etc. Storing the valid information when it is valid is often enriched with other information that comes from IT systems. And when it's all done, then you get somebody who approves or rejects the application, basically makes the business decision. That's a business transaction in our lingo. So what's the problem here? There are quite a few problems. First of all, people that do not have a lengthy education not always understand what is asked. They also may not know where to get the requested data. For example, your yearly income. Right? What is it? Where do I get it? When do I know the number that I'm supposed to fill in is actually right and can be used? It's bureaucratic. Sometimes I have to actually physically go places to get some form, make it into a PDF. If I'm a disabled person applying for a disabled parking permit, I can't use the parking permit to go to of the municipality to actually file this application, stuff like that. On the other hand, there are business challenges, like the verifier or the business designer has to know, how do I know this data is correct, is acceptable? We have seen examples where these verifiers actually go to an online website of a organization, a tax service, or a chamber of commerce to actually check if the information there is the same as on the form. And the basic idea here is you either pay the price of validating as a business, or you run the risk of making a decision with information of which you do not know it's valid. So what we are now adding with self-sovereign identity is a QR code. This is just an example. This is the way we tell it to the business, right? A QR code on the form. We provide a user with an app. We have seen examples of this. The app can scan the QR code and then can find an electronic component at the side of the organization that knows how to find the backside of this form. And the backside of this form is sort of tells in machine readable lingo what has to be filled in, where to get the appropriate verifiable credentials, who should be the issuer, for what purpose this information is used. That's nice for the GDPR. All sorts of other metadata can be stuffed in there. And then this electronic component, say the little robot, and the app sort of communicate how to fill in this form with information that can be validated by the robot in a sense that is appropriate to the business of which the robot is a part. And then, of course, the same thing goes on. The validated information goes to the store. We may not need all the IT links anymore, because if the information from the IT links can be attested to by some kind of an issuer, you can just ask it in the form to be provided by a verifiable credential. So we may not need all IT links. Here are some figures. This is a business case. This is why we do it. There's room for optimization in monetary-wise. We have estimated that in the Netherlands, which for you Americans is the size of Connecticut, it has 17 million inhabitants. We estimated that the total validation cost is over 1 billion euros a year. When we put this figure to the notaries public, they started laughing and they said, "This is wrong." So we asked, "What's wrong?" It has to be much more. So basically, this is a lower boundary of the cost. Another part of the business case, why we do this, is that filling in this form can take a long time. The mean time to fill it in can be days, weeks, sometimes months, if information has to be, if information is wrong and has to be gotten again. We can reduce that perhaps to minutes. Mean time to validate can be days, weeks, and we can reduce that to seconds. There is a very, so there is a lot of time to gain. And of course, we can reduce some IT links. I don't have any estimates on that. Okay, thank you. So this is basically the set of benefits for users and businesses. Since you're taking photographs, I can skip this, and I already told them anyway. But this is what we do it for, right? And we have been doing experiments to show the validity of this talk. Here are some icons, so some logos of organizations that we have been experimenting with. And currently we are setting up an SSI lab, where SSI doesn't stand for self-sovereign identity, but for self-sovereign integration. And it's not just technical integration, it's also process integration, business integration, and vertical integration. Like, how do you get to design forms that have this flip side that is electronically readable? We try to provide support to provide a safe environment for businesses to experiment, because this is a really new idea. They have to get accustomed to these ideas. And one of the ways we see that is possible is making a safe environment for them to do that. And there is lots more. If you know, so if you want to know more about this, then come see me afterwards. That's it.
Thank you, Reeks. Very cool. Any questions?
Hi. Question is, this SSI lab, do you envisage...
Can you...
okay. This SSI lab is a sort of a sandbox, potentially, so you can use it also with to experiment with real users, or is only a an environment where you can play around. So what is your expectation?
We are trying to make that a community effort. Community currently is still rather small, but the original demo that I would have given if we didn't have the discussion this morning would have shown some of the servers we already have running in that lab, and that's it's not all that spiffy yet, but we're only starting. So it's a public thing. People who want to join in this effort, please come see me and let's find out how to do that.
Okay, thank you.
Yeah.
Okay, I'll go to Adrian. Well, go and give it to Trevor.
So you seem ideally located to come up with a hierarchy of standards or interoperability issues that need to be solved. From, this one comes up 80% of the time, this one's going to come up 50%, this one's 20%. Are you looking at, has that become obvious already? Are you able to share this? Or, in other words, simply saying we're going after these benefits doesn't tell us what they expect from the SSI community first.
Yeah, that's a good question. We don't do percentages on stuff, but when we see issues, and I can name one issue that has come up recently, then we try to inform you guys, everyone concerned, to solve it. And the issue that has come up here is the revocation of verifiable credentials. The revocation is something that you shouldn't test. Well, you may test it when you receive the credential, like it is current, for example, in Sovereign. But basically, there can be a time difference between verifying the information or sort of validating the information on the form and actually making the decision. But it's at the point of the decision making that you must know that the underlying information is still valid, so it hasn't been revoked and stuff like that. And if this time is large, for example, with the renewal of a parking permit for the disabled, then it would be so nice if we could have the parking permit issuer use the original set of data, see if it hasn't expired or hasn't been revoked, and then automatically renew the stuff rather than having the disabled person go and do everything again each year, right? And that's why we need revocation at the time of decision. We need the verifiers to be able to check revocation.
Drummond.
Reese, I've heard about EU SSI framework.
Yes.
Can you tell us a little bit about what's happening there?
Yes.
In 1 minute.
Okay, so if I go over the 1 minute, then we'll talk about that later. The EU DG Connect, that's the Directorate General, is one of the Directorate Generals of the EU. Thinks that SSI and stuff is a good idea. In the next generation internet efforts that DG Connect is also sort of trying to push, this is also in there. There is a blockchain observatory or something. There is in the EU some blockchain group which is organized by member states that are trying to make a European blockchain infrastructure. And obviously the first use case on this blockchain infrastructure is going to be identity, right? This identity question has been picked up by a combination of Germans, Belgians, and us. And the idea is we sat together and said, well, let's make a European self-sovereign identity framework. And now we're in the process of trying to figure out how we can put together the consortium, how we can be funded and stuff like that to do that. I can tell you it's not an easy task, but we're trying to.
I think it's really important that we start thinking about Web of Trust for something, so we talk about Web of Trust in a sort of abstract sense. This is about the Web of Trust for sustainable development. So IXO creates a Web of Trust for sustainable development, and we've shown components of IXO over a number of the rebooting meetings, and it's really now sort of come together. And so I'm just going to walk through the use case of Web of Trust for Sustainable Development and point out some of the places in which the specifications are kind of are implemented. And some of it is not visible because of that, because of good UI and UX. So you don't always see the DIDs and so on. But I'm logged in here to the web client, and the resolution is probably not so great. But I've logged in using did auth, and my did is over there. This is my Sean did. I have here a listing of projects. Each of these projects has its own DID and a did document, and all of the publicly available information here is served off of that did document or the endpoints from that did document. So this is all publicly available, and the project is then anchored into the IXO blockchain, which is a Tendermint and Cosmos blockchain. And so we have the did record and did document, but also a ledger of each of the events that goes through. And so we can look at a dashboard as well. So I'm going to now just switch to the mobile. Now, unfortunately, this is a little bit small, but so when I load my mobile app, so this is the mobile client, I can choose to restore my account using a key, using a seed phrase, or I can log in here. With good security. And so I've connected with a number of these projects. I'm connecting at the level of the did record, and this is serving up pretty much what you saw on the website there, but in mobile. Again, here is my identifier that I've now linked onto this device, very similar to what you saw on the web client. And now I want to connect to a project, so I'm going to scan the QR code of this project over here, and that will then link me up back onto my device. So now I can go onto that project and I can choose to submit a claim. So this project is about planet or plastic, and so I'm going to make a claim here that I'm choosing to use recyclables, recycled cups at rebooting, and then I can take a picture. So of course you can put in any information. So there's my paper cup, and I can add information. In this specific example here, we're also looking at ideas for how to crowdsource the data about how people are taking recycling actions, and then suggestions about how to use AI to then verify that and gather more information about it. We can look at previously submitted claims and the claims that have been verified or rejected. So because I'm looking at my own claims, I'm now looking into the project container, which is the data store similar to an identity container, except this is for a project. And I'm able to look at my previous claims. And I'm authenticating with did auth to get into that container. If I go back to the, no, I seem to have lost it. Oh, there we go. If I go back to the project now, I can see on this project, if I look at the dashboard, I can see the claim that's just been submitted, and I can view here each of these claims with the did of the submitting agent. So this is kind of end-to-end. On top of this, you can build financing applications, use the data, which is a high-quality verified data object now, and use that as a digital asset, or use the data for data applications to improve the performance of the projects and so on.
That's it.
Great. Thank you, Sean. Any questions for Sean? Did people understand the jiu-jitsu about credentials and claims? That was pretty cool. Show me the evidence of your claim.
Am I still allowed to use claims?
You're still allowed to, yeah, you're actually verifying the actual claim.
Yeah.
The standards is credentials, but you're going beyond the standard to do something that's tied to real world proof. So that's kind of a different thing than just the credentials, which are about the crypto and whether revocation has happened.
Yeah, maybe just one sort of mention of what's next is, obviously these claims are coming in a sequential way, and they add to a chain of claims. And what we need to do for sustainable development purposes is compare state over different time periods. And so we're looking at, as a next iteration, and this was my advanced reading paper, how do we create graphs of these claims which are still privacy preserving, which will enable us to look at state changes over time, and then backpropagate and look at causality and attribution. Because all of that's important, both to understand why things happen, how things happen, who made it happen, and then to assign value and causality to that.
Very cool. Any other questions for Sean?
What I've been working on is a series of prototypes for an identity wallet. So what you're seeing right now is the main identity screen of that. And these could be Bitcoin wallets or addresses. There's actually a couple of fake wallets in here that's not connected to the network or anything like that. But I can already send and sign transactions. Last Rebooting Web of Trust, you saw me create a conversation between two devices using QR codes where one device would create a secret key and then transfer its public key in a verifiable way to the other device. I'm basically doing that now to sign transactions. That's not the purpose of my demo right now, but I can sign transactions the same way, sign Bitcoin transactions the same way at this point. What I'm actually going to show is the ability to back up and recover your identity using Shamir secret sharing, which is implemented in hopefully user-friendly way. A big part of what, as you've heard me talk about before, my mission is to make this stuff accessible to average mortals who don't understand all the acronyms and so on. One of the conventions I've been adopting, for instance, is help text that's non-optional. So as you scroll through here, you see the help text incorporated here. It's not hidden behind an info button or anything like that. It's out there in plain English where people can hopefully read it and understand it. Because I'd like to educate people as we go. And of course, if you already know how this stuff works, you just ignore the text. I'm open to, feedback on that concept, but that's one thing I've been doing. So to back up your identity, you can basically just export it as a QR code. This is actually the entropy of the entity and its name, just encoded as a QR code in JSON format. And you're also familiar with the idea of a paper backup, which is basically a wallet that you can print. I've got a printout of that here. It's the same QR code on paper. It's one step to restore your wallet or restore your identity from that. The wallets are generated from the identity. What I'm actually going to show, though, is that in addition to that one-step process where if you lose that wallet or if that is discovered by an attacker, it's gone, is the idea of splitting the key up, and rather than calling it Shamir, secret sharing, or whatever, I'm just calling it split backup. And so you can see this there, split your backup into several pieces. So by tapping that, I'm going to read you the text here because, again, I think we should be agreeing on how these things are phrased for average people. Split your backup into several pieces such that no single piece can recover your identity. You specify how many pieces are necessary. Store each piece in a different place or give them to different people you trust so you can retrieve enough pieces if you need to recover your identity. If you use a passphrase to create this identity, you will also need it to recover this identity. And part of the recovery process would be entering a passphrase if you used one, although that may not be as necessary when you're splitting a backup. So as you can see, the default is 2 or 3 shares. I have it set so you can go up to 8 shares, and the reason I chose that is because that prints out very nicely on a single piece of paper. And I have another version of that same piece of paper here that's been cut into these bills, which again would be what you put in safe deposit boxes or deposit with friends or other trusted people that you think you can get enough of them back from. I have that same identity. So if I say, like for example, split into say 4 of 8 here, and I tap split, I get the 8 QR codes, which are the key shares essentially. I can copy them onto the clipboard using that button below. Or I can go to the print dialog again, where you see that I get the print preview that you just saw physically printed out. What I'm going to do here is I'm going to actually show on my iPad here. Let me go over here to import identity. So you can actually see my iPad here. I'm going to go into the same app on my iPad. I'm going to generate a new identity here. This is warm goldfish. That's its fingerprint. This is using my life hash hash visualization algorithm that's open source. Again, the help text is your identity's unique fingerprint, and it never changes. So even if you change the name, that doesn't change. There's your BIP39 backup words, your ability to create a paper backup, or your ability to create a split paper backup. So let's create a split paper backup. And let's say we want 5 shares, 3 of which are needed. So we're going to split that, and I just moved away here because as soon as I move over here, it's going to import the first share. And then if I just swipe to the next one, it's automatically going to import the second share. And then I'll skip the 3rd share here and go to the 4th share just to show that it actually is any 3 of 5. And there's warm goldfish available on the iPhone at this point. And again, just to belabor the point a little bit, I'm going to go import identity here and use my paper bills here. This I actually generate on my Mac Pro at home. And just picking 4 of the random 8 bills here because it's a 4 of 8 share. You're right. So you can, well, actually, it doesn't appear to play my audio for some reason. It might be because it's being shared through. Well, okay. Yeah, I have nice beeps that play for these things as well, but for some reason we're not hearing them through the audio. And there's 4 of 8, and that's Scarlet Shark. So that's basically, again, was generated on a completely different device in a completely different city, recovered here. So that's basically the demo. Any questions?
Awesome, thank you, Wolf.
Thank you.
Questions?
This was developed as part of Blockchain Commons, which is a benefit organization trying to do open source and blockchain infrastructure. In particular, donations from Ryan helped make this possible. So I want to basically say this is a very close to this community and your requirements and all of that. Is why we're doing this. So. Yeah, basically my mandate is to figure out how to make this, what we're doing here, real and get it actually deployed on mobile devices. So, question?
First of all, I just have to say, to see 2 live demos of social recovery and offline recovery happening at Rebooting is a fantastic milestone forward, so congratulations. This is just awesome.
Thank you.
Secondly, do you have a Twitter handle so we can tweet this out?
Yeah, it's just at Wolf McNally is my Twitter handle. And my website is wolfmcnally.com. On GitHub, I'm /WolfMcNally.
Okay, McNally is spelled?
McNally.
Okay, excellent.
Yeah.
Very good. Fantastic, thanks.
Thank you. Anything else?
What information do you encode in the split up keys when you import them? So my question would be, what if you scan something twice? So
right, I can demo that. Each time you split your keys, it generates a different set of key shares. So if you go back to a different code, it will error out with a message knowing that it already got the key share and you must have made a mistake. Or if you enter a key share from a different set, it will know. What I'm actually encoding is there's the JSON document that you see that is just basically the base64 encoded entropy and the name of your wallet, which is what's in this. What's in each of these is that document encrypted with a single-use symmetric password, and the password itself is what's being split. So basically, it's the encrypted JSON document, the recovery document, and the key share, one of the 8 or n key shares that you and then I'm using Don Spreckle's Shamir secret sharing library, which is the same one that HTC is using, which is written in C. And part of what I've been doing for Blockchain Commons is taking things like Libitcoin and the Shamir secret sharing library and so on, and creating Swift APIs to access like for example, Libitcoin is written in C++ and the Shamir secret sharing is written in C. So exporting those to Swift in a very iOS developer-friendly way.
This may be the stupidest question of the day, but from your perspective of usability, what's the difference between what you're doing with Shamir and simply taking a backup phrase and splitting it, maybe not that particular, maybe a more complex one, and splitting it amongst 5 different people?
Well, it's the same. I mean, I would, maybe Christopher has a different answer for this. I would say it's the same as splitting any kind of secret. The backup phrase is a secret. I'm just, in this particular iteration of the code, I'm splitting the entropy from which the backup phrase and everything else is generated. So it's really just a choice of, what you're choosing to back up.
So I'll also answer a little bit on that. So we have a number of procedures that I'm working on for smart custody of how to safely back up an individual key without using social key recovery, which includes things like stamping it on a titanium thing, putting it in a safety deposit that it box, what are the best practices for how to do your inheritance planning and all that kind of stuff so that somebody can get that out of your safe deposit box, etc. Those things don't really work as well with the social key recovery thing. That's another thing. That's if you're in everything, your bank burnt down to the ground in an earthquake or something of that nature. You can still do the social key recovery. So there's 2 very different criteria between both of these recovery things. You want to be able to do both of them.
Okay, one last question, Martin. Did you still have one?
So if you split the passphrase, you need all the information. With Shamir, you need n out of m.
Right.
So that's the advantage from a technical point of view.
Actually, you can do 3 of 5 of the words. Chris can demo that. He does it on some titanium. It's a rather interesting hack. Because the words are discrete, but talk to Chris about it. It's cool. I also wanted to give props out. You mentioned you're using Dan Spreckle's Shamir secret code.
Yeah.
Which is also what HTC is using in their phone. Dan's in the back room. He came this year. He's working on some of the BTCR stuff. So this is definitely
all of this stuff. As we see better APIs, safer practices so you can't screw up, and some new features.
So this is really a community effort, and
It's actually
awesome.
really exciting through collaboration between myself, Don, Christopher, HTC guys, all that.
Awesome. Thank you very much, Wolf.
Thank you very much.
Okay, our last one.
So to give you a little bit of background, so working in humanitarian, we're looking at a solution to provide identity in a better way, in a decentralized way. So there's really 2 components around what we're trying to achieve, is having a device that make it very cheap, very secure to provide identity to people in refugee camp, in some of the most vulnerable places in the world. And at the same time, in humanitarian, they're using more and more biometrics to verify identity of people. The problem is very often it's being done in a very centralized way, and we're looking at how can we do this in a decentralized way as well. So basically, we're trying to use smart cards to be the verifier of the biometrics. So like the verification can be done offline with a card. So in this case and in this demo, I'm going to do with a card. Like if we talk about the Joram example, where they're using a bracelet, that would be also a possibility. It's just a matter of form factor things. So let me try to switch to... Okay, here it is. So here, first I'm going to show you like around the registration how it works. So we can fill like all the information about the person. I'm going to go super quickly and going to do this. So basically, like it's a person, like in the case of Joram, is arriving in Greece, is registering with an organization. So here it's going to, that's going to be super hard. Not looking up, it is. Okay, so taking the picture, so he's coming, he's being registered, so his photo is being taken, his fingerprint is being taken, and so I have here a fingerprint scanner device, and so luckily I can capture my fingerprint. It's taking a little bit of time. So in this demo, I'm using a very small device, but like on the ground, like they're using big device where you capture like four fingers at a time. I'm just going to capture one. And then here, for example, we're going to capture iris. And in the case, so in the case of Joram, like they're talking about UNHCR, UNHCR is using a lot iris scanner. So let's just capture, and you're going to see actually my iris should appear at some point. And so in the ground, when they do registration, they also use like a bigger registration device where you have the two eyes at the same time. And at the end of the process, basically, we can do instant card issuance, where basically here you see the information I entered, so I can print the card, and it's going to create a DID. So here it's an example with EOS blockchain, but it can be with any blockchain. And we can check the here required biometrics, and basically it's going to require the biometrics to be able to access the data. I'm going to show you an example. Okay, so I have my card here. I'm going to put the card on the reader. If I remove the card, the key here, sorry, because this is a key that allows to access everything. So now if I try to refresh, basically, I cannot read the card because I don't have the key and I don't have the biometrics, right? So if I lose the card, nobody can do anything. They cannot access my data because they don't have my fingerprint. So now I'm going to record my fingerprint again. Okay, so my fingerprint has been recorded, and if everything goes well, I should be able to see my identity. So my identity now is accessible. And so if I go to credentials, and here it is. So that was one example I registered before, but basically, so the identity information, all the document, like the verifiable credentials, is being stored on the smart card, protected by the biometrics. Okay, so here I have one credential, which is basically basic information about me. I created another one. We're working on a use case around anti-slavery, how to give more accountability for companies. And so, for example, like this is an example of proof where we would prove that the person has been paid, but we could have an unlimited number of different credentials. So I could add just the medical credentials, fill a form, and then basically sign it with my own key, and it's being stored on the card of the person. So you can share it with someone else. Could just put notes or anything else. Yeah, so that's it actually. Yeah, that's it for the demo.
Wow, awesome.
Thank you.
Thank you. So I'll start with a question. What's the price point on the card?
So the card, like,
at scale, like 10,000.
Yeah. It's depending. Like the vendors are very hiding much of the price, but I would say 10,000 or over is probably $1.50 maybe a card or something like this. So that's really like the important side of this. Like it needs to be cheap. And yes, and those cards can do like EC crypto, so like we can sign things from the card.
That's so awesome. It's so much what we thought was a miracle in a box when we were working on Joram, so it's great to see this come to life.
Thanks.
Yeah. Any other questions? We've got a couple.
So fingerprint recognition is still a probabilistic approach, and each vendor actually has their own algorithm to do it. So how have you accomplished that? Not to mention the universal fingerprint hack, if you've seen this. There's one fingerprint to rule them all, that actually like you can bypass most fingerprint recognitions using the algorithms. So how do you handle that?
Yeah, so we use existing fingerprint algorithm and conversion, so we don't resolve this, like that's out of the scope of the project. The solution is here, like in this demo, we're using fingerprint, but the idea is also to be able to use iris, which is much more secure way of doing, yeah.
Yeah, although from this distance, which is typically your driver's license, I can get a photo of your iris. And
yeah, exactly. But that's the problem with biometrics in general. Yeah.
Not to mention retina and vein palm scanning, the same thing, which is that actually like you can create a fake.
Yeah, your face, like all the biometrics are hackable. Like one of the things is that now what they're using a lot in humanitarian is just biometrics and nothing else. So the advantage here is you need a device and the biometrics. So that just makes it a little bit harder. But yes, I mean, biometrics is going to become more and more a combination of different things. Yeah.
So I suppose if I were a refugee and that's all I had and that's all I was given, yes, but I wouldn't be carrying my Bitcoin billions on that.
Yeah.
I have two questions. So do you have a EOS DID smart contract registry and resolver, and is it open source?
No, so for now, like what we did for EOS, like we just use like the basic account system, so we just have very basic features on EOS. But the idea is more like to be able independent of any blockchain and just support any blockchain that they need, like we don't.
Okay, then I can continue my hobby project. The other question, how important do you think to link the registration process of biometrics to the linking to the card? So the information now went over your computer, so if your computer is compromised, I could have received that data.
Yeah.
And could be identified without my biometrics, correct? So,
yeah.
Yeah, that would be my question. I think it would be important to take the computer out of it and have a hardware link of
directly on the
biometrics.
The problem is, as far as I know, I don't know any that exist. Like I know NXP has a hardware reader that has a fingerprint, but like there's no API to work with it. Yeah, that would be a good solution. So the other option is to use Android devices that are locked down. But then you go to a place like, how do you know that this computer is really locked down, right? Or this device is really locked down? That's very much an issue. Yeah.
Okay, thank you very much. Thank you.
Thank you.
Jeremy, thank you for all of you who survived this marathon of demos.